Factor trees are okay. They're
renewable resource.
yeah, they're friendly. Did you guys find the perfect square sheet? Remember we wrote them up on top there? Corbin, you wouldn't remember your goat's name.
Actually, I do remember.
No, you don't.
Which one?
See? He doesn't remember. Okay, guys. Here's what I'm talking about. What are the perfect squares that are less than 24? Isn't 2 times 2 is 4, right?
Yeah.
Okay, so what's 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. It's not. Okay, so here's my 3 perfect squares that are less than 24. Does everybody see that? Which one of these goes into 24 evenly? 4? 4 times what? So I'm going to rewrite this. And I always write the perfect square first. You don't have to. That's just what I do because that tells me that's what I'm taking out. What's the square root of 4, guys?
2.
Done. What?
I just said 3 times 8, and then
3 times 8.
I broke that down.
Okay. To
I
what?
made 3 prime, and then I did 8 2 times 4, and then I made 2 prime, and then I did it for 4, and then I made 2 times 2.
Okay.
And
So how many pairs of 2s did you have? You can
3.
get the same answer, dude. I'm not saying you can't.
I know. I was just saying, like, if that way it was cool too.
Yeah, that's fine. I just think it's more work.
All right.
There's nothing wrong with doing factor trees. Guys, what perfect square goes into 75? Think of money. Quarters. 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 Oh, thank you. 25 times what?
3.
Why did I break it down 25 times 3? Because 25 is a perfect square. Does that make sense? How many ends do I have? 3, 5. How many pairs? 1 left, right? So when you take 2 pairs out, how many are you taking out? 2. So what can I take out number-wise? What's the square root of 25? What's left? We'll get to the ends in a second. Hang on a second. I got to leave room for my ends. What's left number-wise? 3. Okay, what did I take out end-wise, variable-wise? I took out 2 pairs of ends, which is what? Squared. 2 of them. 2 pair. What's left in here? It's an odd number, so I know I'm going to have a 1 left over. Now, the third one. Think of 2 problems, guys. I got this. I got this on top. And I got this on the bottom. They're both perfect squares. They should break. It's very easy to see. They're both perfect squares. Mary, what's the square root of 4? What's the square root of x to the second? X. Nothing left over, so I don't have to have a radical or a square root symbol. What's the square root of 64, guys? Done. That's all you got to do. Bless you.
You got it, man.
They're not. Answer.
Well, we
Oh, we didn't do them?
you guys just had to finish your notes for homework, right?
Yeah.
Oh, okay.
We didn't get all the way through.
Okay.
They had trouble with the previous night's homework on Friday. So I had him finish the problems and the notes for homework.
Okay. Do you want to go over some of these together with them, or do you want to go over the? What do you
Still
think?
need a couple. Yeah. You still need a extra.
All right,
Yeah.
guys. If I gave you the guide notes, just put them up there. All right. Why don't we take a look at some of these right here? Guys, let's look at 7. Square root of 20. I think it's easy. Let's do perfect square. We'll do 7 perfect square. We'll do 8 factor tree. Guys, what perfect square goes in, multiplies into 20? 10 is not a perfect square. Look at your 4. Right? 2 times 2 is 4. 4 is a perfect square. What times 4 is 20, Logan? Okay, so I'm going to rewrite it like this. And you guys should be writing this down in your notes. I already know how to do this. Okay, why did we choose this, guys? What's the square root of 4? So I'm taking that outside. So this is my answer right there. 5 can't be broken down. Now, look at number 8, guys. Perfect square is this. I'm going to do this, and I'm going to do the factor tree. 16 times 2. Why did I choose 16? It's a perfect square, the biggest one that goes into 32. What's the square root of 16? What's left?
2.
Nope, square root of 2.
Hey guys, quick question. What if you would have chosen 4 and 8? Because 4 is also a perfect square.
Mm-hmm.
What if you would have done 4 and 8?
What if we did this? Isn't this? Right?
What's the problem with 8? Is that simplest radical form? No, because 8 is still 4.
You just do it again. Right? What's the square root of 4? So it'd be, take that out, and there's our 4 radical 2. Okay? Now, factor tree. What do you want to do factor tree? Okay, this is when you guys tell me answers. What multiplies to 32? 8 times 4. Keep going. 2 and 2. What about this? 2 and 4. And that goes to 2 and 2. So 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5. How many pairs? So that's 2 times 2. Radical 2 is left. And you get the answer that way. Why don't you guys try 10? Negative square root of 72, excuse me. What the heck? Am I using your perfect squares? I'm going to try perfect squares. Just what? A couple people? Amazing. What did you get, Logan?
36.
Ah. Samara, why'd we choose 36 and 2? What is it? Yeah. What's the square root of 36? So what's my answer going to be? You're right. Careful. What's outside? Negative. So it's got to go that. It's like a -1 out there. And what's in here? Yeah. Guys, everybody look at 12. That's mental math. You should be able to do 12 by looking at it. You should not have to write that down. Square root of 4x squared. What's the square root of 4, Alexis? What's the square root of x squared? 2x. 2x. Done. Nothing left. Can anybody do 13 in your head? I think that's mental math also. Makana, can you do it in your head? Bet you can. I think you can. What's the square root of 81? Okay, that's the hard part. So there's a negative out there, right? So it's going to be -9. Finish it. Right? If it's m to the third, don't we have 3 m's in there? How many pairs? 1. 1 comes out. Okay, good. Now let's take a look at some of these down here. Remember, treat them what? Numerator by itself, denominator by itself. Everybody look at 15. Again, guys, write it down. Square root of 4/49. This is mental math. They're both perfect squares. Both perfect squares. So what's my numerator going to be, Mary? Think of it like this, Mary. I want the actual answer. 2 over what? Beautiful. That's it. Good job, Mary. Does that make sense, guys? Right? Now, look at 16. Okay, I don't care about the negative outside. I know my answer is going to be negative. Look at the top. Look at the numerator. Square root of 7. Is there a perfect... Isn't 7 a prime number? Right? The only numbers that go into 7 or factors of 7 are 1 and 7. Is that a perfect square? No, so leave it up there. Leave it up there. Can't do anything with it. Okay, what about the 81 though? Is 81 a perfect square?
Yes.
What is it? There's your answer. I'll tell you, 19 is a little tricky. Not too bad. Try it. Again, think of it like this. Two problems. Little bit tricky just because it's a cubed. It's not a perfect square. Just be careful with that one.
For 16, would 9 be negative?
What's that?
Would 9 be negative for 16?
The fraction is negative.
Yeah.
So the negative can go up top or the bottom, but not both. Could also go off to the side.
I would probably write it up front.
Because if you put both top and bottom as negative, what's a negative over a negative? So it changes the value of the problem.
If you would do that negative, that turns to plus, wouldn't it? So, just one of them. Guys, if I was just thinking of this by itself, right? A to the third. How many A's do I have? 3, right? How many pairs of A's?
1.
Just one pair. So 1 comes out. What's underneath? That's my numerator. That's my numerator. What is square root of 49? There's your answer right there. Can't do anything else with it. That's your answer. Now, 20 should be mental math. They're both perfect squares. You should look at that and go, okay, it's this over this. I just heard something come from the vent. I'm still here. Bailey, what do you think the answer is, hon? What over what? You got it. 12 over what? Okay. You said square root of 144 is 12, right? You got, okay. Think of this. How many pairs do you have of K's? So 1, the square root of this is just what? Just K. Can anybody do 22 in their head? Again, 2 perfect squares. So it's 21. What's on top? 5 V over 5V over 6. What's 21? 10 over 2x. Now, if you look at 23, this is the last one we'll do. If you look at 23, can you do anything? 23 is a prime number, isn't it? Unless 23 is a perfect square, I can't do anything with it. Okay, there's nothing that goes into 23 but 1 and 23. So it's square root of 23. You can't do anything with it. Does that make sense? So it's this, but this is what?
8.
That's it. Mr. Westfall, do you want to say anything else, sir? You look like Ultraman and your power's going. Will Ultraman make it? You don't remember that. That was when I was a kid. Every show he was fighting a bad guy and his little beeper went on. You didn't know he was going to make it. But he always did.
You get the next?
You missed that.
Aaliyah? Skylar?
That's it. Guys. Did you want to tell me we got? We got to hurry up.
Yeah, we do.
We got to. I'll start it. Mr. Westfall will tag in. Guys, very simple concept today. Like radicants just means what's underneath the radical square root symbol. Guys, if we want to add or subtract them, they have to be the same underneath. It's very okay. That's it. These are like radicals. These are unlike radicals underneath there. Okay. In other words, I could add and subtract. This would be what? If I added this here, it'd be 6 square root of 5. This would be, if I subtracted them, which it is, it'd be 4 square root of x. Okay? What's in front of this one? So that would be, if I added them, it'd be what? 4 square root of 14. Okay? All right, that's all we're doing. It's not, okay? It's very simple. And then we have to, I'll show you something here in a second. Guys, very simple. Can I subtract those?
Yes.
What is it? 5
3.
square root of 3, radical 3, however you want to say it. Whatever turns your muffins. Make sure you write that down. Not whatever turns your muffins, 5 square root of 3, or radical 3. Ah! Oh, shamanama. Can I add those? No. Guys, you can put already simplified, or you can write that same problem again. If you have a quiz, bless you, you can write the problem again. That tells us you know you can't do anything to them. You can write NLT for no like terms. Already simplified. Write something. Don't leave it blank because you'll miss it on the quiz or test. All right, let's try that one. Do that one. Go. We're going to hurry up. No time to even tell a joke about somebody's. Can't do it. Bailey, watch your tone.
You're saying we're short on time?
We're running short on time.
Sorry, no time. No time for jokes.
No time for him. Bailey's going, I didn't do anything.
We have a
I just
tall
came
task
in.
ahead of us.
We have a monumental feat to get accomplished. All right, guys. It's like that, right? Do I have like radicals? Yes. What's 1 minus 7? So there's my answer right there. Very, very simple idea. Mother hen. Guys, we can have more than one term. Are any of them like terms? Which one? First and what do I got? 11 what, Bailey? Square root of xy plus what? Good job. You didn't come up short on that one. That was a good one. Sorry, Bailey. I had to say it. I just had to. I was short too. That extensions put on. The extensions I'm doing. Okay. Is that the last one? Now starts the fun. Now starts the fun. This will be my last example with you. Then we're handing it over to the maestro. Now, if you look at this quick, what are you going to say? No like terms. But we got to make sure they're simplified. Okay. Just for sake of time, this is what we've been doing, right? And I'm just going to do perfect squares. Isn't 45 9 times 5? What's the square root of 9? So this simplifies to this. Okay. What about 20?
5 times 4.
And you're right saying 5 times 4. I'm going to write 4 times 5 because the perfect square is first. What's the square root of 4, guys? Now I'm just going to keep that negative sign there because that's what it was. They're subtracting the 2. Now, Vince, can I subtract them? Huh?
Yes.
Are you okay, man? Why can I subtract them, Vince? Well, what do they both have underneath the radical sign? Are they like terms? So you can subtract them. What's my answer, Vince? Huh? 1 what? Well, 1 square root of 5. Now, I don't like that. That's a right answer. I like just writing it like that. Okay? There's nothing wrong with There's nothing wrong with 1 square root of 5. I just like square root of 5. Don't you? Man. You don't try to take the pen out of Maestro's hand.
What?
All right. We'll simplify them and see if they have any like radicals. How can we break up 54? 54 is what?
9 times 6.
You agree?
Yeah.
Good boy, Matthew. Now, I'm sorry.
Go ahead.
Why'd you choose 9 times 6?
Since I knew it was a fraction of 9. I just.
I was hoping you'd say something else.
Okay.
Fail. 9's a perfect square.
All right, let's finish that one off and then we'll go over to this one. Isn't this radical 9 times radical 6? So what's this going to be simplified as? 3 times the square root of 6. Now you should always check. Make sure that radical 6 is simplified. It'd be 3 and 2. Would any pairs come out of that one? Good answer. No.
No.
Radical 6 is completely simplified. So that one's done. Now we'll move on to the next one. Radical 24 is what times what? 4 times 6. That is radical 4 times radical 6, right? Radical 4 is 2, and then radical 6. What's 3 radical 6s plus 2 radical 6s? 5 radical 6s. 5 radical 6s. Good. All right. Try this one. Try this one on your own. Ready, set, go. Ready, set, go. How many of you got that? 45 radical 3 plus 10 radical 2. Your check mark should be, have I fully simplified both parts? Okay. Second step. Do I have like radicals? No. So can these be added? No. Your final answer is just simplifying the radicals because we can't combine them. You would just write that as your simplified answer. Does that make sense? Questions? I think it's kind of fun.
I think they're fun.
Go ahead and quickly try this one. Did you get that? Nope. Better give you enough time. Go too fast. Are you guys okay? Go too fast. No like radicals? Can't subtract them? Hmm. Are any y's going to get pulled out? Are any y's going to get pulled out? No. Both of those y's are going to be left inside. Okay. Now, don't we have to ask ourselves, are any numbers getting pulled out? Isn't 12 4 times 3 times y? Isn't 27 9 times 3 times y? Yes, yes, yes. What is the first radical simplified as? Dorian, what'd you get?
I haven't.
Well, just take a look at this one. Help me out. What is this one simplified into?
That would simplify.
Can anything come out?
You get let's think 2.
The square root of 4 comes out as a
Two.
2. Can anything else come out?
I don't think so.
I don't have any pairs of 3s.
No, baby.
I don't have any pairs of y's.
No.
So they stay in and multiply, right? Second one, Dorian. Anything come out?
3 come out of 9.
Yeah, square root of 9 is a 3, and a 3y is left inside. Would you look at that, Bailey? You get 5 radical 3y's, don't you? Don't you now? You have 2 radical 3y's, and you have 3 more radical 3y's. Now you have 5 radical 3y's. Does everybody understand how I got there? All lines up here. Please help me out. Are you guys okay now with going from this step to this step? Are you all okay with that? We're taking the square root of the perfect squares and bringing them out. Leave everything else aside. Let's do a couple more if we have time. Or is that the last one? We have more, don't we? Yeah. What do we want to break up 48 as? Yeah, you could do 6 times 8 to break up both of those. Mary?
16 and 3.
16 and 3? That'd work. Why'd you think 3, Mary? What kind of got you thinking about that?
I don't know. I just plug random numbers.
That's fine. I see these other 3's up here, and if it's going to simplify, they're going to have like radicals. So that's a good thought. All right, first one. Corbin, what does the first one simplify into? Do you know? Corbin, look up here. Square root of 25 comes out as a
5.
What's left inside?
3y.
Good. Braden, next one. What comes out?
3.
And it's multiplies to that 2, and you get 3 times 2. And that 3 multiplies to that 2, and you get a what?
6.
Good. 3y left inside. Last one, a 4 comes out. Look at all those like radicals. Now I do 5 minus 6 plus 4. What is that? 3 radical 3y. Would you look at that? Fully simplified. What the heck? The homework for it's on the hold on. I deleted the one slide. Here we go. Ready? It's on tonight's agenda. 490, page 490. I'll just copy and paste it here. Come on. There we go.